Okay, so this is just a quick little demonstration and breakdown of the hardware present in the current version of my augmented woodwind sensor project. I'm also going to talk just a little bit about what will be going into future revisions of the prototype moving towards a final version. So at the moment, this effectively kind of hard to make out mass of wires is the prototype of the board. So everything that is currently in the prototype version is attached to this board, with the exception of any expansion modules, which I will show the current prototype of one that I have in just a moment. Just to break down exactly what is on here, we have this board right here, the ESP32, and this board is going to be kind of serving as the main controller for everything. Everything gets wired into it, and that's going to essentially be running the code that this board will be running. In addition to that, you'll notice two other boards on here, and I'm just going to pull them out. Everything is attached to the prototype, just with little sockets, making things nice and easy to remove. I have this chip right here, which is effectively going to be handling the gyroscope and accelerometer elements. So here we have this chip. And then I also have this one right here that is handling the air pressure sensing that will come in from this attached tube. Now, at the time, this is the current sensor I'm going to be using. However, I will likely be replacing it for an airflow sensor in the next revision. However, right now, this is what we are using. In addition to that, a few quick non-removable elements to this prototype board are two buttons, and you'll just see them right here by my thumb, the red and gray ones respectively. They can be hit by the performer in order to trigger elements and things of that nature. There's also an LED attached to the corner that will light up and flash when the unit is powered. Alright, so those are the core chips and elements here. Everything is kind of wired in with the various resistors, and then the bottom of the unit has additional jumper wires and some tape just to help prevent any accidental shorting. Again, this is kind of, again, the first version of the prototype, so there's a lot more wire here than there really needs to be, and one of the goals of future revisions will be to reduce the footprint of this unit, but for now, everything is expanded. Connected to the board are three main items that we can find right here. The first is the battery used to power it. Right here, this is just a simple 3.7 volt lithium ion battery. I have a few different sizes I've used for prototyping, but I kind of stick with the large one just so I don't have to charge it as frequently. Next to that, right here, it kind of blends in with the background just a bit, is the power switch. So this is what will, again, just toggle the power off and on, so that way I can easily power the unit as needed. And then wired into that is also a small little USB-C circuit board that handles all of the charging as well as the pass-through to get the power from the battery into the unit. So for right now, the unit can be charged or effectively run directly off of 5 volts of the USB-C power. So again, you can take any USB-C cable and you can charge up the unit. Let's see, the board itself actually runs off of 3.3 volts, so there is a little voltage conversion here just to make sure everything runs properly, but you can plug it in from the wall without issues because of that conversion right there. At the moment, again, there are the two different USB connectors. The ESP32 board itself can receive data through a wired connection with a micro USB. So again, you can connect this to the computer either while using it or in order to update or change data just with the wired USB micro connection. Future revisions will work to combine these two into one functioning USB-C port, one that will handle both data and power through the same interface. All right, the last element here are the expansion ports, which we can see some sockets for right here by my thumb. There's a 6-pin header and a 4-pin right here, although this 4-pin only has only has 3 of them that are functioning at the moment. So the 6, I should say, handle the power and ground distribution for the expansion boards, and the 3 handle any data return. At the moment, there's only one expansion board that's been prototyped, and I have that over here, just with a slew of wires, but it's pretty straightforward. Just the power comes in through this little ribbon cable, and we just connect it power to ground to those 6 terminals right there, and then each one, in parallel, we can connect up to 3 force sensing resistors that will eventually be attached via a removable bracket to the instrument in order to tell how hard the performer is pressing on those pads, and then the data is sent back out to the main board through these 3 wires on the left side of the screen. So I don't currently have any of the force sensing resistors plugged in the prototype. It's a little loose, so they tend to fall out or have an unstable connection, but those just connect right there, bridging those 2 docking connectors kind of in the middle of the board. And that is the expansion module. Plans for the future mainly focus around the expansion modules, other than condensing and improving the various elements in the main board. The next one that I plan to be focusing on is a small microphone, not in the sense that it will be able to pick up and transmit high quality sound, but it can be used to determine when sounds by the performer reach a certain threshold, and that can be used as a trigger in the computer for the processing. The other immediate update that I plan on adding is a small switch similar to this one. Let's get the focus right there. There we are. Similar to that one, that can be used to toggle between the wired and wireless modes. So by toggling the switch in one direction, it will only send communications through the wired port, which again will eventually be a USB-C connection. And by toggling the switch in the other direction, it will default to the wireless transmissions, which will be the default setting regardless. The goal is for the eventually completed and condensed unit to be attached to the instrument, so that way the gyroscope and accelerometer chip will be able to pick up the movements of the performer. These movements will then be transmitted to the computer, where the computer will be able to take the incoming data and perform effectively whatever the user wants to program, but the idea will be to be using it mainly in audio and visual aspects for a live musical performance. So next, I'm just going to kind of real briefly go through the code that is going to be present on the board as it stands right now. I'm still in the process of testing and revising and testing and improving and so on, But the next element of this video will just be a quick breakdown of all of the code that is currently written for the unit in its most up-to-date version. So stay tuned for that. Okay, so this is the code for the current version of my augmented woodwind sensor that I have right here. We are getting a few little error warnings. I started this up on a separate computer, and I just haven't told this computer where to find all of these libraries yet, so it's getting a little angry at me right now. But generally speaking, I'm just going to go through the whole code here just so we can see everything that it has. And I'll mention a few updates and things like that, features I want to adjust in the future. The first part is here are all the libraries. There's one specifically for each of the additional circuit boards. So the gyroscope sensor, the air pressure sensor, things like that. Then a few things for the communication. So the Bluetooth communications, setting up a timer that I'll get to, things like that. So basically, I'm just going to kind of go through this. I would like to, in the future, kind of break this up into smaller sub-files that can all talk to each other, but for now, it's just in one fairly long-ish file. So this first section here is just setting everything up, defining all of the variables and things like that here, and the pins and things of that nature. I'm definitely going to be going through here and just condensing all of these, because I've tried to be economic, but a lot of times if I need something, I just go and make it real quick and then work the code, and then I've changed around and rearranged and deleted some things. So I'm just gonna in the future go through and remove all the things that I don't need. But for right now, this is all of it right here. I do have to set up and initialize everything, get it up and going, and then here we get the setup function. So this is a fairly standard, just a little bit of setup for Arduino. I'm just telling the board what pins to use and whether it's an input or an output. It's pretty straightforward right there. I have it commented out currently, but this is also where it's going to check the switch that I'm going to add, just to enable whether it's in wired or wireless mode. For right now, I'm keeping it in wired mode, so that way I can very easily, put the code on the board and then test it, and then, update the code, dump it to the board, and so on. So right now it's staying in the wired mode, just because I cannot wirelessly drop the Arduino code onto the board. So then this is setting up all of the wired and wireless stuff. I'm then setting up a timer here that every 300,000 milliseconds or 5 minutes, it's going to check the battery level and report that back. I'll point out that function a little bit later. After all this is set up, it's just going to run a little light sequence, just so that way the user knows, hey, everything is set up and we are ready to go. I'll go through the process as we go along here, but here's the loop that repeats. It's a little long at the moment. I'm going to see if I can find ways to condense this, but actually I think there's a way that I can do it just with a for loop within the loop function, but we'll get to that in just a moment. But basically, I'm just taking the sensor reading from all of the sensors I have at the moment, which is just the gyroscope, the accelerometer, the air pressure, the 3 fingers sensors that can be additionally wired in, and then the 2 buttons. Again, I plan on adding additional ones later on, but I'll be kind of formulating how that's laid out moving forward. Once we've got the sensor values, we're essentially going to check if those values are, good enough to transmit. So I want to eliminate any noise from the signal, sending a lot of data that can slow things down, things of that nature. So I've got this set up to where for that sensor, we're going to check the previous value that we got from the sensing in the loop against the current value. And if it's larger than the threshold I have right here,
then and only then will we transmit the data. I am in the process of fine-tuning what these thresholds are for each of the sensors. It's just a long process. The buttons are the easy one because the buttons just go either 0 or 1, so it's either on or off. But the rest of these, again, it's a little bit of fine-tuning. So I've got a bit of a placeholder now, and then I'll fine-tune it as I go through more and more checks and revisions to find that nice balance between fast, accurate data and eliminating unnecessary transmissions. After that, here's where we assign the current value of all of the sensors from right here to become the previous ones. So again, this will just keep cycling and replacing those values. There's also just a little check here for if there's any data being sent from the computer to the board. It's not doing anything with it, but again, it's just a way to check, hey, did something come in? And it'll let the user know by returning a value, hey, you sent this in. The board will not respond directly normally. The last thing it'll do is tick that timer. And I do need to, I think I will fine tune this. I have to figure out exactly how fast the loop is going to be running and maybe adjust that 300,000 value. So it's approximately every 5 minutes. After that, I have all of the kind of customly defined functions that is everything that the board will currently do. The first one here are that light setup that I mentioned. So the in version, there's going to be 2 separate LEDs. At the moment, only the main LED here is what is wired into the board. It's just going to basically flash twice and then stay on once the board is running. The other one, the one labeled power LED, it's a little confusing. I will admit I may change those. But this light will only turn on when the battery power is low and should be charged. I'll point that out in the next function. But that just flashes, or it turns off and on and then back off, and then it stays off until we need to turn it on. The last thing we receive is a message through both the Bluetooth and the wired connection that everything is set up, everything's ready to go. The user can start whenever they're ready. Underneath that here, I've got a function that is going to be checking the battery level. So basically, it's just going to read in the battery from a pin, and I do need to, once it's all wired up, just double check which pin we'll be using it on, doing a little bit of math in order to determine, what that approximate percentage is. And then if it's wireless, it'll send this through the wireless connection. Otherwise, it'll send it to the wired connection. But it will tell the user that the battery is at approximately this percentage. So that we'll have that right there. If that percentage is less than 30%, then we're going to get an additional message that the battery is low. Please charge it before the next performance. And then it's going to write that LED power to high, so it'll turn on that light. Otherwise, it just makes sure that the light is off. And then this second bit is just doing the exact same thing, but only if it's going through the wired connection, not the wireless. And then this is just because of the library, we need to return the value true just to keep the timer going. All right, the next section here is a little bit of the sensing functions. So again, this MPU read that's reading from the accelerometer and the gyroscope. And basically, it's just setting up, it gets all the data from that board. And this applies to both of these sensors. But we're wanting to monitor the accelerometer and the gyroscope separately. So I have it set up so that if we're specifically checking for the accelerometer, we'll get the accelerometer data, which we've stored in some variables here, and return that as an array of 3 values. The same thing with the gyroscope, just with the gyroscope values there. I think I may change one thing now that I'm looking at it, because I can see this being problematic right here. So I'm just going to say return A there. A. And remove it there, just because I do know, as I mentioned, I'm still in the process of updating and testing it, and I haven't worked this far down in the code yet. But I do know not having multiple returns in a function can be problematic. So since we're only doing one at a time, we can run that pretty easily just with the one return right there. Underneath that is a function for checking that air pressure. So we're just checking that, and it's essentially taking the average values every time we go in, and it'll just return that periodically. It's pretty straightforward. I do have, because again, I haven't gone this far in the fine tuning and testing, that's going to take several weeks to do. But I do have some of the old checks right here that I don't want to use anymore, but I don't want to delete them until I'm confident in how this works. And like I mentioned, I'm probably going to be changing the board anyways, so this will all probably get changed shortly. That's how that will be working right there. Actually, while I'm here, I actually don't even need this because I know that works. Okay, underneath that is this sense value right here. So basically, up in the loop up above, I'll just scroll back up to refresh your memory. Right here, we're running the sense function over and over again with different arguments to tell us which sensor to use. That's kind of detailed right here through this fairly long conditional statement. Basically, if it's the sensor for the index finger pressure sensor, it's going to read from that pin and store it, map it to a nice value range, and then we will store that as a variable and then return that variable at the end. And that's essentially what each of these are doing. It's just a separate pin reading this data right here, and then the gyroscope and the accelerometer and the airflow and air pressure have a separate function, but it's the same idea. And then if it gets something else that's not one of these sensors, it will just let the user know that, hey, that's not something we were looking for. Try that again. Underneath that, I have that value mapping function, just to make sure everything is nice and normalized. So again, that's why I have to fine tune those ranges. But essentially, we're going to come in, divide the value, and set it up as a kind of a low footprint bit of data that'll get streamed through either the Bluetooth or the wired connection for that. Underneath that, we have the check function, which is going to tell us whether or not these values that we received back from the value mapping and the sensing are in the range for transmitting. So basically, to avoid any potential negative numbers and dealing with that, I'm squaring the values of everything coming in. So we get, the label, the previous value, value 1, the current value 2, and then that trigger, that range, the limit that tells us when to transmit the data. So we're just seeing if the new value minus the old value, so again, just the change in those values. If it's larger than the cutoff, we're going to run the transmit function with that same label and that value, that new current value that got sent into the checking function. And it's pretty straightforward here. It's just going to decide whether or not we are sending the data wirelessly or through the wire. And it's just going to say, send the label and then the data. The label is pretty important. This is how Max is going to receive the data from the computer in order to use and work with it. So again, I'm going to be fine-tuning all this, but all of these labels here, you'll notice it's ring for the ring finger, the third finger sensor, or the button, whatever. Then there's a space after all of them. That way, when Max receives the data, it has label space value like it's used to working with. And then from there, it's essentially just routing the values to certain things in Max, being able to control various parameters and things like that. I don't think I'll be able to, I won't be able to really look at the rendered Max right now. But in this kind of collection is just a sample Max patch, which actually I might be able to run if I just real quick. I'm just going to pull that up, but I just got to remember where I put it. That is right. What is this called? I'll tell you what, yeah. Well, I'll cut out part of this and pull up the Max, but it's essentially functioning how I said it was, where it would send the values in. Max would look for certain labels and then route the number to whatever you need. So that's essentially it. I'm gonna kind of end this video right here, and we'll keep working on this and keep going for the future. I'll be updating all the stuff as we go, creating new things, new versions, and fine-tuning this into a great final project with hopefully some interesting applications in the realm of some dissertation work. All right, so I'm gonna sign off now, and I'll see y'all next time. Bye.